America's project to nuke the moon, Project A-119. Project A-119, also known under the title A Study of Lunar Research Flights, was a classified initiative devised by the United States Air Force in 1958. The project's goal was to detonate a nuclear bomb on the moon. This dramatic act was intended to shed light on unresolved questions in planetary astronomy and astrogeology. If the nuclear device had exploded on the moon's surface rather than within a crater, the resulting flash could potentially be seen from Earth with the naked eye. The underlying purpose was to demonstrate U.S. technological prowess and bolster national morale, particularly as a countermeasure to the Soviet Union's early advancements in the space race. The project was ultimately abandoned when Air Force officials concluded that the risks of the operation exceeded its potential benefits. Additionally, the prospect of a manned moon landing was recognized as a far more inspiring achievement for both American and global audiences. Had the plan been executed, it could have set a precedent for the militarization of space. Similarly, a corresponding Soviet project, Project E-4, was also scrapped. Concerns included the risk of the warhead accidentally returning to Soviet territory and the possibility of sparking an international crisis. The existence of the U.S. project was disclosed in 2000 by Leonard Reifel, a former NASA executive who had overseen the project in 1958. A young Carl Sagan was among the team members tasked with assessing the consequences of a nuclear explosion in the vacuum of space and its low gravity, as well as determining the scientific merits of the endeavor. The documents pertaining to the project remained classified for nearly 45 years, and despite Reifel's revelations, the United States government has never officially recognized its participation in the study. During the Cold War, the Soviet Union established an early lead in the space race with the successful launch of Sputnik, one on October 4, 1957. This event marked the first time an artificial satellite was placed in orbit around the Earth. The unexpected success of Sputnik, coupled with the United States' failed attempts to launch its own satellite under Project Vanguard, led to widespread concern and was termed the Sputnik crisis by the media. This catalyzed the onset of the space race. In response, the United States initiated a number of new studies and projects to regain its footing. These efforts included the successful launch of Explorer 1, the establishment of the Defense Advanced Research Projects Agency, DARPA, and the creation of NASA. In 1949, the Armor Research Foundation, ARF, of the Illinois Institute of Technology initiated a series of studies to explore the environmental impacts of nuclear explosions, continuing these investigations until 1962. In May 1958, under the guidance of the United States Air Force, which had originally proposed the idea, ARF discreetly began to research the potential effects of detonating a nuclear bomb on the moon. The primary aim of this program was to create a nuclear explosion visible from Earth, intending to bolster American morale during the intense period of the Cold War. At the time Project A-119 was being developed, there were widespread media reports fueled by a rumor that the Soviet Union intended to detonate a hydrogen bomb on the moon. According to press accounts in late 1957, an anonymous source had informed a U.S. Secret Service agent of Soviet plans to mark the anniversary of the October Revolution. The plan allegedly involved coordinating a nuclear explosion on the moon with a lunar eclipse on November 7th. These reports mentioned that the Soviets aimed to target the dark side of the Terminator, the line dividing the lunar day from the night. Project A-119 also considered this critical boundary as the potential site for its explosion. Additionally, it was speculated that if the missile failed to reach the moon, it could potentially return to Earth, posing a significant risk. Edward Teller, often referred to as the father of the H-bomb, proposed a similar concept in February 1957. He suggested detonating nuclear devices both on the lunar surface and at some distance away from it. The aim of Teller's proposal was to study the effects and implications of the explosions in such an environment. This idea underscored the period's intense interest in nuclear research and the potential military and scientific applications of nuclear technology in space. The planned explosion for Project A-119 was intended to take place along the Moon's terminator, the dividing line between its day and night sides, to maximize visibility from Earth. A specialized 10-member team was assembled under the leadership of Leonard Reifel at the Illinois Institute of Technology in Chicago. Their research focused on three key areas: assessing the potential visibility of the explosion from Earth, understanding the scientific benefits, and evaluating the implications for the lunar surface. Among the notable members of this team were astronomer Gerard Kuiper and his doctoral student, Carl Sagan. Sagan's role was particularly critical. He was tasked with the mathematical modeling of how a dust cloud generated by the nuclear explosion would expand in space around the Moon. This analysis was vital for determining how visible the resulting dust cloud would be from Earth. Initially, scientists involved in Project A-119 contemplated using a hydrogen bomb for the lunar explosion. However, the United States Air Force quickly dismissed this idea due to the substantial weight of such a device, which exceeded the lifting capabilities of the available missiles. Consequently, the decision was made to use a W-25 warhead, a significantly smaller and lighter option with a yield of only 1.7 kilotons. For comparison, the Little Boy bomb dropped on Hiroshima in 1945 yielded between 13 to 18 kilotons. The plan was to mount the W-25 warhead on a rocket and direct it towards the shadowed side of the Moon. Upon impact, the warhead would detonate, creating a dust cloud. This cloud, illuminated by the sun, was expected to be visible from Earth, providing a dramatic demonstration of U.S. technological prowess. Leonard Reifel, the project leader, noted that advances in intercontinental ballistic missile technology by the Air Force would have made such a launch possible as early as 1959. Project A-119 was officially cancelled by the Air Force in January 1959, primarily due to concerns about the potential risk to the global population if the launch were to fail. Leonard Reifel, the project leader, also highlighted additional concerns regarding the implications of nuclear fallout. He noted that such fallout could compromise future lunar research and hinder the prospects of Moon colonization, making the risks associated with the project outweigh its potential benefits. These considerations led to the decision to abandon the plan, prioritizing safety and the long-term scientific value of the Moon. Subsequent investigations in the 2010 revealed that the Soviet Union did indeed have a similar project, although the earliest official documents date from 1958, a year later than the rumors that spurred the U.S. project. These findings indicate that the real Soviet plan differed from what was initially reported in the press. The Soviet project, under the codename E, comprised several stages. Project E1 aimed to reach the Moon, while Projects E2 and E3 were designed to send a probe around the Moon's far side to capture a series of photographs of its surface. The culminating effort, Project E4, envisioned a nuclear strike on the Moon as a demonstration of Soviet power. Like the American initiative, the Soviet E-series of projects was ultimately cancelled during the planning phases. Concerns about the safety and reliability of the launch vehicle were primary factors in this decision, reflecting similar apprehensions that led to the cancellation of the U.S. project. The exploration of detonating nuclear devices on the Moon was ultimately curtailed by significant international agreements. The Partial Nuclear Test Ban Treaty, signed in 1963, prohibited all nuclear detonations except for those conducted underground, effectively ending the feasibility of nuclear tests in space or on celestial bodies. This was followed by the Outer Space Treaty in 1967, which further restricted the use of nuclear weapons in space by banning the placement of nuclear weapons or any other weapons of mass destruction in orbit around Earth, on celestial bodies, or in other outer space locations. Prior to these treaties, both the United States and the Soviet Union had conducted several high-altitude nuclear tests. The U.S. operations included hardtack Boantar, Argus, and Fishbowl, while the Soviet Union conducted Project K, among others. These tests explored the effects of nuclear detonations in the upper atmosphere and near space, but the subsequent treaties reflected growing international consensus against the militarization of space and nuclear proliferation, ensuring that future endeavors to detonate nuclear devices on the Moon would be prohibited. By 1969, the United States had achieved a monumental milestone by becoming the first nation to land a man on the Moon through the Apollo 11 mission. In the same year, following the success of this historic lunar landing, Apollo scientist Gary Latham proposed the idea of detonating a smallish nuclear device on the Moon. This proposal aimed to advance research into the Moon's geological composition by creating new opportunities for scientific study. However, the suggestion was quickly dismissed, primarily because it would conflict with ongoing plans to measure the Moon's natural background radiation. Scientists were concerned that detonating a nuclear device would significantly alter the lunar environment, thereby skewing the data and results from these measurements. The need to preserve the integrity of the natural lunar environment for accurate scientific assessment was deemed more critical, leading to the rejection of the proposal to use nuclear explosions for geological research. The details of Project A-119 remained under wraps until the mid-1990s, when its existence was uncovered by writer Key Davidson during his research for a biography on Carl Sagan. Sagan, who later became a renowned astronomer and science communicator, had been part of the project team during his early career. Davidson stumbled upon this information when reviewing Sagan's application for a scholarship at the Miller Institute at the University of California, Berkeley, in 1959. In this application, Sagan included details about his involvement with Project A-119, specifically mentioning the titles of two classified papers. The papers, titled Possible Contribution of Lunar Nuclear Weapons, Detonations to the Solution of Some Problems in Planetary Astronomy, from 1958, and Radiological Contamination of the Moon by Nuclear Weapons Detonations from 1959, were both sensitive and classified. Davidson viewed Sagan's disclosure of these titles in his scholarship application as a breach of national security. This inadvertent leak provided a rare glimpse into the secretive nature of early Cold War-era space research and raised questions about the management of classified information in scientific communities. In the midst of his scholarly activities, Carl Sagan referenced a 1958 paper titled Cosmic Radiation and Lunar Radioactivity, authored by Ia Filosofo, in a 1961 paper he wrote for the United States National Research Council. This paper was one of 8 reports generated by Project A-119, which focused on the implications and effects of nuclear detonations on the Moon. Unfortunately, all of these documents were destroyed in 1987, contributing to the mystery and scant details surrounding the project. Sagan's mention of the paper in 1961 highlights the continued interest and discussion in the scientific community about the potential scientific outputs of Project A-119, despite its ultimate cancellation. The destruction of these reports has limited detailed understanding of the project's full scope and findings. The biography Carl Sagan: A Life was released in 1999, and it was shortly followed by significant media attention when a review in Nature magazine highlighted the discovery of the leaked information pertaining to Project A-119. This review prompted Leonard Reifel, who had until then maintained his anonymity, to publicly respond by writing a letter to the journal. In his letter, Reifel confirmed that Sagan's disclosure of the classified information was indeed considered a breach of the project's confidentiality at the time. Taking this opportunity, Reifel disclosed further details about the project, his revelations catching widespread media attention. In discussing Project A-119, Reifel also expressed his personal disapproval of the project's motives, stating he was horrified that such a gesture to sway public opinion was ever considered. His statements not only provided insight into the secretive project, but also reflected his ethical stance on the implications of using nuclear detonations in space as a show of force. The increased public interest and scrutiny that arose from the publicity surrounding Leonard Reifel's revelations and the correspondence in Nature led to a Freedom of Information request being filed concerning Project A-119. This action finally resulted in the declassification of A Study of Lunar Research Flights Volume 1, making it publicly available more than 40 years after the project's inception. Further inquiries into additional documentation were met with the discovery that the other volumes and reports associated with the project had been destroyed by the Illinois Institute of Technology in the 1980s. This destruction of documents significantly limited the amount of information available to the public and researchers, leaving many aspects of Project A-119 shrouded in mystery. David Lowry, a nuclear historian from the United Kingdom, has been outspoken in his criticism of Project A-119, describing the proposals as obscene. Lowry emphasized the detrimental impact the project could have had on public perceptions of space exploration, suggesting, had they gone ahead, we would never have had the romantic image of Neil Armstrong taking one giant leap for mankind. This comment reflects the concern that detonating a nuclear device on the Moon would have marred the historical and cultural significance of subsequent peaceful explorations, such as the Apollo 11 mission, which captured the world's imagination and admiration. Don't forget to give a like, share, and click subscribe to receive notification when we drop new content.